factor and solve polynomial equations. So just in case, because I know it's Thursday, so you probably haven't done your notes yet. If you have, then that's great. But I'm just going to put them up here for reference. We have two new special factoring patterns. One is for the sum of two cubes, which is if we have a cubed plus b cubed. Notice there's no parentheses around this stuff. This is just a term plus another term that's being cubed. This would factor into a plus b times a squared minus ab plus b squared. And then the difference of two cubes is basically the same thing, the signs are just different, is if we have a cubed minus b cubed, that factors into a minus b times a squared plus ab plus b squared. And if you haven't done the notes yet, the little acronym that I use to help keep the sign straight on these is SOAP. One of my students shared this with me, that they had been taught this before, and I was like, oh, that's really smart. And so I started using it because I always had a hard time keeping straight the signs on this stuff. So this means same, opposite, always positive. So when we have something like a cubed plus b cubed, same sign goes in here, so it's a plus b. Then opposite sign, so this becomes a negative because this was positive. And then always positive, the last sign will always, always, always be positive, regardless if it is positive or negative one. Down here in the difference, same sign first, then opposite sign, and then always positive. And so just like with the stuff we were doing yesterday, with the, a cube of a binomial, that one, obviously we said, okay, we're just copying down the number, the sign doesn't go with it. That's still true for this as well. So this will make more sense when we start using numbers. Factor by grouping is also in this section, which we've done, obviously you've done before, so we'll do a little bit of that, but not too much. So the first one, just say to factor completely. So that can be, that can be any kind of factoring, but it will include factor by grouping. So number 4, I've got 30b cubed minus 54b squared. So anytime I have a problem like this, my first thought is going to be factor by grouping. So I want to take out the biggest thing from each piece that I can. So what is the common thing that I can take out of these pieces?
2b squared.
So I can take out something bigger than 2, but b squared is correct.
6. My brain.
Yep, 6. 54 is a weird one to look at, but to know what number comes out of it. But so 6b squared is the biggest thing I can take out, and I'm left with 5b minus, 9? Yeah. And that's as far as you can go with that. So this one is purely just a factor by grouping problem. 6 z cubed minus 6z squared minus 72z. So general rule, when we have something like this, we want to see if there's anything we can take out first, and then from there we'll see if we can factor it down any farther. The previous one, there was nothing more to factor. But what can I take out of all three of these pieces?
6z.
Just z. There's no 6 in front of this one. So just z. and just one of them. So I have z times z squared minus 6z minus 72. So now once I'm here, I want to see if I can factor what's in here more. So I would need factors of negative 72 that add up to give me negative 6. This is probably a weird one that you wouldn't necessarily normally use. If we need to, we can also do a factor tree over here. So 72, 8, and 9 are kind of the easy factors. 8 can break up into 2 and 4. 9 is 3 and 3. And then see if there's any combination of these numbers that I can multiply, like sets of them together and get something. I can even break down 4 into 2 and 2 if I want to. Yep, negative 12 and 6, because I can do the 3 and 2 times 2, so that would give me 12, and then the 3 and 2 there. So I'm going to have negative 12 and a positive 6. So this becomes z times z minus 12 times z plus 6. Remember, we can do this because there's no number in front of z squared. If there was a number in front of z squared, we would need to rewrite the whole thing and then do factor by grouping. So this would be it factored right here. Eight, 54 m to the 5th plus 18 m to the 4th plus 9m cubed. What can I take out of this? Yep, 9m cubed. And that'll leave me with 6m squared plus 3m plus 1. And then I need to see if I can factor what's in here. So are there factors of 6 that add up to 3? Or what are our possible factors of 6? 2 and 3. Add those together, we get 5. What else? 6 and 1. If I add those together, I get 7. So this is as far as it can go. So this one would get left here. It can't be factored any farther. All right, so we're going to move into the sum or difference of cubes problems now. So number 10, I've got x cubed plus 8. So obviously in the formulas that I gave you, it was like a cubed plus b cubed or a cubed minus b cubed. Well, I only see a cubed sign on x, obviously, or like a cube on x. But is 8 something cubed?
2 cubed.
8 is 2 cubed. So I usually rewrite this as x cubed plus 2 cubed because it helps me to see when I go to write in the formula, because a lot of people will forget and will just start using the number 8 instead of the number 2, which is what they really need to use. So to factor this, it's always same sign, so you copy these down exactly just without their powers on them. So the first parentheses is always going to be exactly whatever this is, just pretend the cubes don't exist. So x plus 2. So that's the same sign part. Then in the second parentheses, we're going to have 3 things in here. The first number is whatever the first value is. So in this case, it's x squared. Okay, so we ignore the cubes on here for everything once we get down to like actually factoring it out, because I'm just putting it into the formula. So this is going to be x squared. So x is representing A and 2 is representing B in our formulas right now. So we have the SOAP formula, same sign. Then we have opposite sign. So that's going to be negative. And then it's the first term times the second term, but because I like x written at the end, I'm going to write 2 times x. So minus 2x. And then lastly, we're always positive, so plus the last term squared, which is 2 squared. So you can either write it as 2 squared, or you can go ahead and write it as 4. I usually just go ahead and write it as the number. But if you want, just for reference, I'll put the visual there that was 2 squared, the way we got that. Because if they give you a problem that, say, the variable and the number's flipped, that way just make sure that you are aware of exactly what happened. So it's very different probably than what you've done before, because I'm assuming you probably haven't seen this before. But it's really not hard as long as you know the formula. So, let's see, 12. 27m cubed plus 1. So the nice thing about these problems is they tell you that these are sum or difference of cubes problems, so that you kind of know what you're looking for. If it didn't tell you that, because like the instructions like on your quiz or your test will just say factor the polynomial completely. Like that's what it's going to say. And all factoring ones are going to be that way. So you need to look, just like we look for special types like difference of squares or perfect square trinomials, you kind of have to look for a sum or difference of cubes. So is 27 something cubed?
3 cubed.
Yeah, 3 cubed. What about 1 though?
1 cubed.
It's 1 cube.
A lot of people get tripped up by that and they're like, this isn't a sum of cubes. I'm like, but it is. Like 1 can be cubed raised to the 100th power. Like it doesn't matter. It's still going to be 1. So I usually will rewrite this as 3m and then that whole piece cubed, because 3m is going to be A in my formula. So that whole piece is that. And then plus, and I'll rewrite this as 1 cubed, just again for the visual to show that both things are cubed. If you don't write it this way and you just go straight into factoring it, that's fine. I just like it for me to be able to see what I'm plugging in. So copied exactly, same sign. So 3m plus 1 will be in our first parentheses. Then our second one is the first term squared, so 3m squared. So I'm going to do this in 2 steps here. So 3m squared. Opposite sign, so it was positive, so I need a negative sign here. And it's the first term times the second term, which would be 3m times 1, so that's going to be 3m. And then finally is always positive, and that would be 1 squared or just 1. Now, I did this 3m squared piece just for a visual for you. You could go straight to 9m squared. I'm just showing it in 2 steps so that we see exactly what's happening. So my factored form would be 3m plus 1 times 9m squared minus 3m plus 1. So that would be it truly factored out then. And if you're ever not sure, say you get to the quiz and you're like, I really don't know if I factored this correctly, like did I remember the SOAP formula, did I do it right? You can always do what we did in the section yesterday where you're going back and you can check it by essentially, well, what I would call superfoiling. And you can verify once you do this that you get back to this. If you don't, something's wrong. And most likely it's a sign. So those were 2 sum of cubes ones. Let's see if we can do a difference one. 14. 27a cubed minus 1,000. So the 27a cubed is just like the 27m cubed that we had in the last one. So I'm going to treat that as 3m, or not 3m, 3a, and that whole thing cubed. What about 1,000? Yep, 10 cubed, so this will be minus 10 cubed. So, what would go in the first parentheses for factoring?
3a minus 10.
Yep, 3a minus 10, so exactly the same sign, copy down as it's written. What would be the next, or the first number in the second parentheses? And you can go straight to the answer. You don't have to write it like I did in the last one.
9a squared.
Yep, 9a squared, so the first term squared. What's this sign going to be?
Positive.
Positive, because it's the opposite sign here. What is the middle term going to be?
30.
30a.
Yep, 30a, so it's the first term times the second term. And then what about the sign in the final number?
Negative. No, positive. So
Yep, positive, always positive, and what's the last number?
100.
Yep, it's 10 squared would be 100, and so that is it factored. All right, one more of this kind. It seems like y'all are pretty much getting it, but I want to make sure we see something here. 192w cubed minus 3. So, is this one something cubed? No. But it's in the sum and difference of cubes problems. Any ideas what I might need to do?
Take out a number.
Yep, I'm going to try to take out a 3. It's probably my best bet. So I'm going to factor out this 3. 192 divided by 3 is
64. Yeah.
Yep, 64. Get rid of that. So this would be 64w cubed minus 1 now. So I factored out that 3. Now, the catch is you cannot just drop that 3. The most common issue with a problem like this is people just being like, oh, I'm just going to get rid of the 3. It doesn't matter. I don't need it, whatever. So now I need to do, that's weird, a difference of cubes. So what cubed is 64? Yep, 4 cubed. Yep, 4 times 4 is 16 times another 4 would be 64. So 4w, and I write that in parentheses cubed just so I keep that term straight, minus 1, and I'm going to put the cube on it. So the very first thing I would do when you have a problem like this is I would, sounds like there's like a bird or something, I don't know, is I would write down that 3 so you don't forget it. So I'm going to put this 3 here before I ever write my first parentheses. So then what's going to go in this first parentheses now?
4w minus 1.
Yep, so copied exactly with the same sign. And then what's going to be the first number in the next one?
16w squared.
Yep, so the first term squared, which would be 16w squared. What about this sign? Plus, yep, so the first one times the second one, so 4w, and then last sign and last number. Yep, plus 1, always positive, and that is just 1 squared. So this would be your answer for this one. So the difference is that we had factored out a 3. So once we did that, everything's the same, but we had to get it to where it was 2 things that are cubed first. How do y'all feel about this?
Pretty simple.
Not too bad. All right, then the last step in here is truly factor by grouping. So what they have essentially done is they've taken a problem that was that you would have factored, like an x squared plus whatever, plus something, and they have done that first step of finding the factors for you, so they're just doing the factor by grouping. So it's kind of funny that they teach this, like, after we've done factoring, but
Yeah, you would think
You-
that they would start off.
yeah, like I feel like they would have, yeah, I don't know. But anyways, we'll just do like one or two of them. I think y'all already know what you're doing. So 20 is n cubed plus 5n squared minus 9n minus 45. So obviously these are a little different than your like just basic factoring, but what we're doing is exactly the same thing. So I'm going to factor the first two terms in the last two terms. So what can I take out of these first two? Specifically an n squared.
Oh, yeah.
Because there's, yeah. So then I'm left with n plus 5 here. And anytime we're like doing factor by grouping, what's in those parentheses should match, even though these have higher powered terms to them. Okay, so just like when we do it in normal factoring, it should be this work the same way. So what am I taking out of this one?
-9.
-9. And that leaves me with n plus 5. So these two parentheses match. So now what I have is n squared minus 9 times n plus 5. But because this was something that was higher powered, I should always see if I can factor it any farther. So can I do anything, obviously not with the n plus 5, but can I do anything with that n squared minus 9?
You take the. I'm thinking you could possibly take the square of it. No.
So this is, I'm going to tell you, this is a special type.
Oh,
plus 3
And
squared.
square.
that would be a perfect square trinomial. What's the other one? Starts with D.
N plus 3 and minus 3.
Yep, difference of squares. So this will factor into n plus 3 and n minus 3. And then ultimately we also bring down that n plus 5. So this is it truly factored. So because this is the highest powered term here is cubed, we could have up to 3 factors. Obviously something could be repeated, but in this case we had truly 3 separate factors. But you can never have more factors than whatever your highest powered term is. So, which this will lead us into what we'll do right after Christmas when we come back. We're going to finish up chapter 5 just because I don't want to leave 3 little sections hanging before we do trig for 9 weeks. So we'll like finish up the last 3 sections. But anyways, this will lead us into what we're doing for the last 3 sections. But that's a problem for after Christmas. All right, one more of these. 25x cubed minus 100x squared minus x plus 4. So I'm grouping the first two and the last two. What can I take out of the first two?
25x squared.
Yep, 25x squared. And that leaves me with x minus 4. What can I take out of the last one?
-1.
-1. So that leaves me with x minus 4, which is good because I wanted these things to match. So now I have 25x squared minus 1 times x minus 4. Am I done?
No.
What do I need to do?
I'm blanking out. I know what it is, but
It's just like the last one.
the difference of squares.
Yep.
5.
Yep. So 25 squared, or not 25 squared. 5 squared is 25. So that's like 5x squared minus 1 squared. So what would this give me? Difference of squares.
5x minus, or 5x plus 1, and then 5x minus 1, and then x minus 4.
Yep. So it's just doing that difference of squares there in that last part to get us to our final answer. And that's all that's in this section. So problems are 7,
Just an idea. We should make the people who left do the problems, and then just us not do the problems.
Yeah, y'all need to work these. Let's see, 11, 15. 17 is a little bit weird. I'm going to tell you, you're going to need to factor out a negative number.
Okay.
Because it will end up being a difference of cubes. But the way that it's written at the moment is negative 5z cubed plus 320. So you're going to need to factor out a negative number to get it in the correct form for you to be able to do that problem. And then as far as the factor by grouping, let's do 21 and 23.